Hey guys, Jake here, coming at you with another math problem today. Here's the problem we're going to be going over today. Estimate the area under the graph of f of x equals 1 over x from x equals 1 to x equals 2 using 4 approximating rectangles and left endpoints. So I have already done this problem using right endpoints, but I wanted to show you what it would look like using left endpoints as well. So there's you can go check out that other video about the right endpoint method. But here we're going to be using the left endpoint rule. So it's going to be similar, same kind of process. We'll first start out with the formula for the left endpoint rule. So basically the left endpoint rule says that if we want to estimate the integral from a to b of some function f of x, we can estimate that using the sum from I equals 1 to n of f of x sub I minus 1 times delta x, where delta x is b minus a over n, and x sub I minus 1 is a plus I minus 1 times delta x. So basically what we need to do is figure out how to, basically the integral that we're trying to figure out is the area under this function here, 1 over x, from x equals 1 to x equals 2. So that tells us basically the bounds of our integral are 1 and 2. And the function that we're trying to find the integral of is 1 over x dx. So we can estimate that using this summation here. So this summation, we want to kind of plug in the information we know, which is, first of all, the number of rectangles we have is 4. We're using 4 approximating rectangles. So n is going to be 4. So we're going to have the sum from I equals 1 to 4 of f of x sub I minus 1, which is just f of this thing here, a plus I minus 1 times delta x. Well, our delta x is just going to be b minus a, which is 2 minus 1, all over n, which is 4. So we're going to get this times 1 over 4. And then we need to multiply that by delta x, which is again just 1 over 4. So pretty much what we need to do here is just iterate through this equation here. Or I'm sorry, we actually know our a as well. Our a is 1. So we'll put that here too. So we need to iterate through this equation here, starting with I equals 1, then going to I equals 2, I equals 3, and up to I equals 4 is going to be our last I value. So first of all, when I equals 1, we're going to get, and we'll kind of keep a list here of all these terms. So when I equals 1, we're going to get 1 minus 1, which is 0, times a fourth is still 0. So we're going to get f of 1 times 1/4. So f of 1 is just going to be basically going to our function, 1 over x, and plugging in 1. So if we get 1 over 1, that's just 1, times 1/4. So 1 times 1/4 is 1/4. Then we want to go back to this and go to I equals 2 and plug I equals 2 in. So plugging 2 in for I, we're going to get 2 minus 1 is 1. 1 times 1/4 is 1/4. 1/4 plus 1 is 5/4. So we're going to get f of 5/4 times 1/4 from right here. Okay, so our function f is 1 over x. 1 over 5/4. You want to keep in mind, basically 1 over 5/4. Dividing by something is the same as multiplying by the reciprocal. So this is the same as 1 times 4 over 5ths, or 4/5, which is just 4/5. Right? So f of 5/4 is 4/5. And then we need to multiply that by 1/4. So we're going to get 4 over 5 times 1 over 4. The 4's are going to cancel, and we're just going to get 1 over 5. Okay, now we need to do I equals 3, which is going to give us 3 minus 1 is 2. 2 times 1/4 is 1/2. 1/2 plus 1 is 3/2. So we're going to have f of 3/2, which just means plugging in 3/2 into 1 over x, which is going to be 1 over 3 halves is the same as 2/3. And then we're going to have to multiply that by 1/4. So we're going to get 2/3 times 1/4. The 2 will cancel with one of the 2's here. And we're going to get 1 over 3 times 2 is 6. So 1 over 6. Then we need to do I equals 4. Plugging in I equals 4 up here is going to give us 4 minus 1 is 3. 3 times 1/4 is 3/4. 3/4 plus 1 is 7/4. So f of 7/4 times 1 over 4. F of 7/4 is just going to be 1 over 7/4, which is 4/7, times 1/4. The 4's are going to cancel, and we're just going to get 1 over 7. So now we basically have to consider the fact that we're taking the sum of all these terms. So all we have to do is add up 1/4 plus 1/5 plus 1/6 plus 1/7. And I'm not going to go through all the computation of figuring out what this sum is, but if you just plug that into a calculator, you'll get 319 over 420, which is about 0.7595. So that's it. That's our approximation of this integral, or the area under this function from x equals 1 to 2, using the left endpoint rule. So hopefully you found this video helpful. If you did, please give it a like, subscribe to the channel. Those are great ways to help support my channel so I can keep making more videos like this. Thank you, and see you next time.